All right, we're back in Advent of Code 2016, day 9. Explosives in cyberspace. Wandering around a secure area, you come across a data link port to a new part of the network. After briefly scanning it for interesting files, you find one file in particular that catches your attention. It's compressed with an experimental format, but fortunately, the documentation for the format is nearby. The format compresses a sequence of characters. White space is ignored. To indicate that some sequence should be repeated, a marker is added to the file, like 10x2 in brackets. To decompress this marker, take the subsequent 10 characters and repeat them 2 times. Then continue reading the file after the repeated data. The marker itself is not included in the decompressed output. If parentheses or other characters appear within the data referenced by a marker, that's okay. Treat it like normal data, not a marker, and then resume looking for markers after the decompressed section. For example, Advent contains no markers and decompresses itself with no changes, resulting in a decompressed length of 6. A1x5 BC repeats only the B a total of 5 times, becoming ABBBC for a decompressed length of 7. And so on and so on. Okay. And the puzzle input looks like this. So we need to parse string and decompress it, I guess. Let's go to here and put something here. We just need one line. Can delete this. So we have we get the length like this. So we just have this. For a length of 6, I guess. Yep. So we can, the next example, and obviously that's wrong now, because we need to decompress the B. So we need to we can just walk through the string until we see a bracket. And then we scan until the next closing bracket. And then we just have to remember that and start decompressing. This example is interesting because we do 6 times 1. So these 6 will be repeated once. It becomes 1 times 3. The 1 times 3 looks like a marker, but because it's within the data section of another marker, it is not treated any differently from A. It comes after it. It has a decompressed length of 6. So we don't recursively decompress here. So let's just get a marker. To go through the line, I guess. And We find a letter, then we just go forward. We find this. Then we need to change the string. You can always take the rest of the string and then apply this kind of function on the rest of the string, which is repeat this. Now we get a new type of rest of string, which is then this. And then we continue walking. So if our character is if it's bracket, then it's special, right? We need to scan the rest of the string. So we always want the rest of the string. Let's just say while done is false. Okay, while not done, we just continue. And we either say we also kind of like parsing. We go into kind of want to get the first index of first. First index of the first character matching the given predicate. Substring here. Okay. Trans a substring of this string that starts a specific start index and continues to the end. Yeah, so first we get the index of this bracket closing. And then we just take till the index. This is the, what do we call this? marker, I guess. We can update the current rest. We can need to parse the marker to find out if like it markers basically something like marker, and we want to get whatever. Then we get something like this. Yeah, no. Okay. Now I have a marker which has a length and times. Length is this, and then the times is this. Then I can process this marker immediately. Because I need to update the current rest. First of all, I already update the current rest by starting after the marker part. Then I need to apply the marker. Returns a string. So now I have a marker, 3 times 1, AC, BC. And I'm going to output tripling the 1B and C. So I have substring or take marker dot length. Repeat marker times current rest. Well, this thing. How do I repeat a string? And just do it naively. I mean, we can also repeat it 1 minus and return x plus current rest. Okay. And then we have changed the current rest. And then the else is we have any type of letter, then we just increase our counter, which is a thing that we need. Oh, wait. Result. And then we print result. And then we might be off by 1 or something, but let's see. I think we're off by 1 somewhere. So this, some print line debugging. Okay. Okay, current rest equals cool. So we remove the RA, then we have 1. Then we move the bracket, and we have 2. I wonder what this index is. Obviously, I need to go to current rest. Let's try it now. It's quite good. Index 4. Then bracket in 1. Okay. We don't really want the bracket. Maybe I should just get rid of the bracket immediately from current string. See what happens now. Okay. Replace everything with bracket close. Scale one. Let's go here. 1 and 5. Cool. So the marker is 1 and 5. Then we have the current res is 1 times 5 substring at the index, which is 3, which gives us, okay, we need one further. Just do that. Cool. We get the BBBBBC. And then at the end, we're empty. Nice. So if current rest, this done is true, then we get 7. Cool. Then we get the next example. 9 is correct. And another example. 11 is correct. Here we have the double one, which is interesting. 3. Should be 6. Okay, so my code just applies duplicate, right? Let's look at what happens. Okay, the first thing is that we just replace the 1, 3. So we need to add some variable about how many we replaced, which is here. Number of replacements is, I mean, the marker knows how much we replace, right? We can also do it here. Times. Here, this one. And then we do just do it here. Say we have 0, and then we update it to this. Every time we take 1, we reduce it here. Use it, but less than 1. And then we have to have 0 to be able to go in here. Now we get 6. Okay, so if we made some replacements, then we update it by how many we did, how many characters, number of characters that were replaced. And then while we're reading the string, 1 character at a time, we reduce it until we hit 0. And then we're allowed to replace again. Yeah. And then we have another one of these. 18. That's correct. Okay, let's try the big one. Pretty slow. Did end also, that's good. And we're good, we're on to number 2. Apparently the file actually uses version 2 of the format. In version 2, the only difference is that markers within decompressed data are decompressed. This, the documentation explains, shows much more substantial compression capabilities, allowing many gigabyte files to be stored in only a few kilobytes. Okay, that's the same. And now we decompress twice. So this should get I get 18. Maybe we should get 6 ABC sequences. 19, I guess. Let's see. Here we definitely have 324 and they have 241,000. Okay. So I think we can just replay. We just don't care about this. See what happens. Yeah, 241,000. Let's see. 20? Yeah, because of the X and the Y. So it's 20. And this one, 445. Easy peasy. That's cool. Our code can do both. Now let's do the big one. And now let's just run it. Let's see. I think it's printing too much. But we can just run it and see. I think it's not ideal to recreate a string all the time. And it's kind of a nested structure. So it sounds like we should be using recursion. I don't know how far we are. Looks like we still have a string. But the number is not too. Oh, is it growing? Well, it should be growing. Question is how long is the string still? Oh, it doesn't look crazy long. 12,000 jars. I want a bit more trust. How long was the original? 12,000. Hmm. 8,000? 7,000? Think we're getting somewhere? I don't know. Oh, 17,000? Also wonder if I should turn off the printing. Oh, I can't copy it anymore. If something like this is in there, 11,000, 1,100 characters times 6. And you can resolve the inside one. And you don't need to resolve it 6 times. We always have to do everything. Like these next 1,100 ones, I have to do the same stuff 13 times. I wonder if even in my code, I can just leave the code and optimize it a bit with a hash map. Hmm. One thing that would help is if how far we were. Oh, no, we're almost done. No, we weren't done. Almost okay. Um, I think this is quite heavy, right? So if I can this something that I can hash. the current rest is too variable. Could take the marker outside, or just even make smaller function. Keep the part. Here, I put it back together. I do it here actually. This here, and this doesn't need the rest. Because of this repeat part, it's this small string, and this is the one that can. Basically, this is the part that does this. This. I check if pair current rest and marker. Like this is kind of function. Mm-hmm. Not sure this is great, but let's see. I'm gonna do this that often. I also wanna million. Where did we go last time? See how far we got last time. Yeah, last time we only got to 2 million, so this is already better. Because now we're at 9 million. I think we got to 3 million last time. Somehow the thing is gone. Oh, Java heap space. Hmm. Wait, maybe I can just give Java a bit more memory. Start. Let's do this. Any memory optimizations we can do. Can do this more idiomatic. Hmm. Wow, it's really not that big. That means we get a lot of hits. I can profile. I'm curious. Um, Actually, I can't because I don't have the pro version. Hmm. Mm-hmm. Not sure if I what I can. Hmm. The mark. I don't think the mark. I think this is not great. How do I get this better in Kotlin? So You know what would be cool? I know I need to do this. Mm-hmm. Work. Oh, I want to repeat it this minute. It works. Uh, let's get the. Oops. Where is the input? This one. Probably not the issue. Let's see how this is implemented. When the actual fun. Yes. Okay. See if it breaks at the same time. You can have more memory. See, it only takes two. See if it actually takes four. I think it doesn't. Two, three, four. But why actually? I mean, the string is 25,000 characters. The hash map has 155,000 entries. Or maybe the hash map is too big. Hmm. It doesn't actually need this. This times. This could be in. What should be string int? I'm sure if that really helps though. Oh, I might have a lot. Oh no, I won't have a lot because it's just another int. This thing part is annoying. It keeps all the strings in memory somehow. then overloads. How do I get it to not do that? Or just give it more memory? Hmm. One more memory? What this actually? Okay, so this is the same. Capture memory snapshot. What does that do? No, it's here. It is fine. If that doesn't work, we start Googling. Check the monitor as well. Interesting. Even though I give it more memory, it stops at the same. Did restart actually? Hmm. Why? I also don't really need something with strings taking too much memory. Hmm. Am I running this more often? Maybe. Could just try another map. String. Mm, further. Also not. The rest is hovering at 25,000. Many function calls. Getting too big or something. Google a bit maybe. Okay, so I'm thinking basically I think the correct solution is to rewrite it in a recursive way and not actually use the string, but just make a function that returns um, the 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 length of resolving the basically an int, and this just returns the length of how many um, characters this will produce, and you can make it recursively, so it can recursively return the characters. So apply this replacement recursively, and then at the bottom case you get the length. But I want to try one more thing because I think this is quite good. We have a map that's not crazy big. We can get quite far, but I think the problem is that we're saving the whole current rest in the map. So each key is really big. And I want to see if I can just hash the work again. Um, uh, how do I get it? Some kind of code snippet. Massive stitch. Get this guy. Um, I just My byte array is my hash. So I just start a hash. And if I actually don't really have that much because the output is still long, right? Let's try anyway. Let's see what happens. Put it in half at least. It's not ideal though, because we still have all this current string business. If we have 80,000 times 25,000 stars, of course it's gonna get super big now. I get double as far, but still not able to finish. I should break now. Yeah. Oh, that's annoying. I guess we need to write the correct solution. I don't care about this anymore. We need to apply the marker. Basically, we can start changing this function here. We need to say we don't have a marker if Now, if we have a marker, then we repeat the part, marker times length, blah, blah, blah. Then we look for a marker here. New rest. Um, new marker. Okay, and then we have a marker, which is like I get a marker or a mm, a bracket open. If we just even say mm, mm, mm. If it starts with a, let's say, if it starts with this, it should return 1 plus extra space 3 BC, then it should be BC, extra, just lines here, BC, and then the marker is x1. So basically, Marker C is null. Then I have to check. Basically, if marker equals null and current rest starts with not starts with this, and we do in this case, we just return 1 plus apply marker substring. Then we have marker equals null. We do have a starts with, and we need to do this get marker stuff here. Um, yes, right. And then the actual current rest. And a marker. How do we do it? That is just split on. Every to next rest. And we have a marker. And then we have else, where we have a marker. In this case, we do this stuff, I guess. Take our rest, repeat it, repeat the part a number of times. And then we apply marker on the rest. Cool. We just return that. And then this is all unreachable, I guess. Why? Let's go here. We just call again. We go unreachable still. Why? Ah, why is it unreachable? We reach it here, no? Oh, now it asks me when marker. Nee, that's very weird. Let's do it like that. Now it says -1. Hmm. Marker is null. So we go to here, right? This is the first one, 15. Okay. Yeah, we have it repeated now. Bam, 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 bam. Okay, that's cool. Yes. What? Wow, we get really far. That's weird. Wait, do I? Hmm. That's stupid. So this way. The last dress is 53 times 15? That's weird. Hmm. Somehow there's a bug in it. Here. 15 times 10. What's happening? Hmm. If there's a here we have no marker in this part, so we just go 1 plus. Then we go here we have no marker, but it does start with brackets. We go here new res. is what thing is this? New marker is X. And new marker is get marker. Right, next rest is current rest. Split. If current rest left. Okay, breakpoint. Debugger. We're here exactly. Oops. Let's go here then. The marker is 15 and 10. And the next rest is because it splits at every bracket. That's stupid. I should just open from the code that I had, which was substring IDX. Or maybe substring IDX plus one. Let's check this one. Uh, okay. New rest dot substring IDX plus one. Okay, let's run this. See what it does now. Stack Overflow error. Okay, now we do a lot of function calls that are recursive. So now we can get a map. Okay, and then we can do pair of int. Then we say if I just have an annotation for this. Anyway. Um, I mean, this one doesn't need it, but here, I guess. If B and M, then P double P equals a pair of Okay, let's do this message digest again. Actually, that's not over optimize. Let's just do it. String. Okay, next rest. New marker. And then we have m of p equals result. Return result. Then we do the same here. Then we do this. If I can just do it. Okay, like just 3 rounds. Or it's it is better to do it inside the function. If let's add it here. Current rest marker. I just do this and then this. And then result. Then I return result. Read likes this more. Nope. Okay. See you again. I need to check if it actually works. That's fine. Some crazy one. So I could maybe I could just mark it in this. I mark also the rest. Then what happened? Mm-hmm. Crazy what works again. Yes. Okay, so difference is instead of appending the repeated part and the current rest and handling that in my recursive function, which makes a large string, I can actually just handle the repeated part, process it, get the number out of it, how many characters this creates, and do the current rest in a separate function called process this one, process the rest as well, and then I add those numbers, which results in the same, but is computationally better. Because I don't make the string bigger and bigger, I actually reduce the problem. So let's try the big one again. Okay. I mean, this is really deep. Also not all this, but just process it in here. Mm. Next index of bracket is the current rest. Find first index of first bracket. Oh yeah, I can just do this. Mm, how does this behave now? Oh yeah, wait, I don't want to go here. Mm, why does it behave strangely now? And that's because of my thing, or what? If it really works or gives me wrong results. This is right or not. Does this work? Oh, still stuck. I feel like we're too complicated. Can't be this hard. Let's just restart. Basically, we want if the current rest starts with. We want to do something. And definitely this whole marker stuff. Here, let's just rewrite it. I don't care. Let's see. Index is current rest at first. First, this one. Then we have marker equals current rest substring 1 until index. Or we could do it like marker raw is current rest substrate dot split. I was here earlier with this, but whatever. Just take it. Well, not just the first part, but drop one. No, let's just do index of first again. Okay. Index. Marker part is take index. New rest is dot substring. Okay. Then we have marker. Okay. Um, Okay, let's get the marker like that. And then we have let's say we have marker rest, which is current rest, length. Then we have new rest is length plus one from there on. Then I just apply a little too simple for now. And then we also have um, let's what's this do now? Mm, what? All right, like that. Hmm. Wait. Whoa. What happened? Okay, that's a very large number. Let's try it. That's it. So, so the solution was to throw out all our previous code and we start more simply by just doing simple recursion where we pass the current rest in at the beginning. Then we have a function that takes a string and returns a long. The base case is the string is empty and we return 0. And then there's the two cases. We start with this bracket thing, then we do our special stuff, or if it's not bracket, we just go through our string and say, okay, it's one character and count it and apply the function to the rest until we hit the bracket. So then in the bracket case, we do our logic to get the marker. So we have marker, length and times. Then the trick now compared to the previous code was we just take the part of the current string rest that the marker applies to. So this is like a substring. Say it's 15 long, beginning here. 15 characters. So we go from after the closing bracket to 15 characters after the bracket. That's the rest. And then, so this is basically this. That's exactly 15, but this is the input. And the marker is this, right? The marker rest is this. And the new rest, everything after this. This part. That's the new rest. And then we can put the marker rest into the apply marker or process function. And it can reapply underneath. So the assumption is obviously that within a reapplication, it doesn't go out of the bounds, which seems to implicitly hold here, because otherwise it would be computationally more expensive. So every subroutine can then handle this substring, this one, the marker rest. So just handle it once and we times it by marker times. Even if it's recursive, we can just process the problem once, break it into a smaller part, and then multiply it by how often we need to process it, and then we can just apply the rest. And that's how it's super fast, because it actually just processes everything once, even if it has to be processed like 10 times, like in this case. So yeah, it's some kind of hidden assumption that I can do that because this would be 20. I process this side of here. I think it might need more characters from outside, from the rest string that we now completely cut off here, the new rest. But given the data that they give here, it seems to work. So that's the solution. See you next time.